Hello my dear students, I am B S Pandey, your physics lecture in series of standard 12 video lecture. My dear students, today we are in lecture number 83 and hopefully the second last topic of this chapter. It is alternating current. We are studying of NCERT chapter number 7. Okay, so let's start today's lecture. It is the very important lecture, my dear students, that you will study one of the electric device. It is called transformer. All right, so let us start today's lecture. It is lecture number 83. Chapter number 7 of NCERT, alternating current. Our topic is transformer. My dear students, you have seen the transformer in your colony, in your home as well, but it is very difficult to find the transformers inside the home. So I would like to recall you the transformer that you have seen in colony. You might have remember outside the apartments or in a colony, over the poles, it is loaded as a heavy box. That is the heavy box, all right, of iron. It is the transformer. Why actually this transformer used, and what is this transformer? So try to understand. Actually this transformer, it is very clear with its name only, transform. All right, so it's used to transform. All right, it used to transform the voltage. Remember, it never transformed the current. We used to transform the voltage at different amplitude. It might increase the amplitude, that it might increase the voltage that we supply, and it might decrease the voltage that we supply as input. It means this transformer has two basic work. One, it is to either increase the voltage or decrease the voltage. At power station, we use a transformer. It is of one type, and in household circuit we use a transformer that is of another type. All right, there are two types of transformer we will study, but the basic use of this transformer is to transform the voltage at different amplitude. Remember, it is quite obvious, my dear students, if we are using this transformer. Remember, we will study actually the working principle and how this transformer works. But before that, you should remember, we know that alternating current changes its amplitude. All right, the peak value, it changes its value, the amplitude changes in alternating voltage. But in direct current, DC voltage, often we have a study that the amplitude remain constant. It is not necessary, the amplitude might be changed, but we have studied the current remain constant. All right, current remain constant. So transformer actually used to change the voltage using the change in current. Actually, all right, change in current. It works on mutual induction that we will study, but it used to change the voltage using change in current. But in case of DC current, we know that its amplitude remain constant. That's why this transformer basically used to transmit the alternating voltage. Remember, we don't use in DC circuit. All right, in DC circuit, if we are using in DC circuit, then we have to change the amplitude of the voltage and current as well. Okay, so it used to transform the voltage at different amplitude. Now it is very important, my dear students, it is very important that why this transformer used and what was the need necessary of this transformer. All right, yes, look at here. Suppose if we are sending from power station, this is the power station, we are sending some power as it is power input, and it reached to the household circuit or colony. Alright, you know that from power station your colony is too far, so the length of the conductor will be very much. Okay, the length of conductor is very much. Here the power sent by the powerhouse should reach the power, suppose it is final, to the colony. Alright, that is the power station and colony. Why? If there is no loss of power, what we expect? We expect that we should not lose the power. We should have the maximum efficiency of the transformer. So in this case, my dear students, you can understand this power is nothing but the voltage into current. Alright. Take an example to understand this one. Why this transformer was needed? Why it is necessary to use in household circuit or in electronics. So suppose we need 200 volt and 10 ampere. Alright. Suppose 200 volt and 10 ampere. How much power? So the power it will be, it is 2000 watt. How? Using this formula, E times I. Alright. Now here the power should reach how much? Of course it is P final, it will be the 2000 watt if there is no loss in power. I hope you are getting. Now look at here, my dear students, the 10 ampere the current. 10 ampere the current, what will do? Actually we know that H is equals to I square R. Alright. Already we are having the too much length of the wire, that will increase the resistance. Okay. Resistance directly proportional to the length. So larger the length, the larger will be the resistance of the wire. If current will be maximum or higher, what will happen? The heating effect will be high. From power station to colony, there will be large number of heating loss through this wire. Alright. I think large amount, not the large number, but large amount of heat loss through this wire. And then what will happen, my dear student? The power sent by the power station, it will not remain the power received by the colony. And this loss of heat energy will reduce the efficiency of our transformer or reduce the or increase the costing of electricity transmission. So what we do actually, we try to decrease the current. Remember, because we require the resistance, we require the wire for the electric transmission, so we cannot decrease the resistance too much, but we can decrease the current. So to decrease the current, look at here, if we will decrease the current, suppose it is 5 ampere now. Alright, it is 5 ampere. Now, if you maintain the current at 5 ampere, what should be the voltage to have the power 2000, my dear students? Could you say? Yes, to maintain this one, you have to change the voltage, and I think it remains 400 now. 400. So voltage you have to increase. If you want to decrease the current, then you need to increase the voltage. And in this case, the power remains same. The input power equals the output power. If you are thinking, sir, increasing the voltage, again, the power will increase. But remember, in that case, if you are recalling this formula, H equals to V square over R times T, then in this case, the resistance will divide this voltage. Alright, this resistance will divide this voltage. So increasing the voltage is not very much loss, in power transmission, but increasing the current is not very much fruitful for us. So we try to increase or decrease the current while the transmission, and to decrease this current or increase the current, actually we are changing the voltage. That's why we use a transformer. Okay, my dear students, in this case, in this way you can understand why the actually this transformer required. So overall conclusion from here, my dear students, we can have high voltage, low current can be converted into high current and low voltage. Okay. Here you can see we are decreasing the voltage. Alright. This is the input section and this is the output section. Alright. So this is one kind of transformer we will use to study. It is known as the step down transformer. Step down transformer. Alright. Now another one, my dear students, if high current, low voltage, this is the current and this is the voltage, converts into high voltage, low current, then this is another kind of transformer and this is called step down transformer. Step down. Alright, this is called the step down transformer, in which low voltage convert into high voltage. If high voltage convert into low voltage, this is step down. We are decreasing the voltage. We are increasing the voltage. This is the step. This is the step down. Sorry, this is the step up transformer. Step up transformer. We are increasing here the voltage. Na? That's why this is the step up transformer and this is the step down transformer. Okay. The principle, remember, this question will be asked in your examination. Actually, the principle on which this transformer works is called mutual induction, that you have studied in electromagnetic induction. Okay, so you should remember the principle. It is called the mutual induction. So you should write principle it is mutual induction. Okay, mutual induction. Now, how this transformer works and how it looks like, try to understand in construction and working. Construction and its working. Okay, my dear students. So let me draw first here a transformer, a sketch of transformer. Look at here. This is the core of transformer. Remember, this is the core of transformer. Actually, it is the laminated. Okay, laminated core. And this is not the, it is made up of the soft iron. Soft iron core. Now remember, my dear students, this is not the one piece of the iron of this particular thickness. Actually, the large number of stripes of this shape, that is the square shape, alright, in between it is empty, we are used to fetch and then staple to get the transformer. like this one. They are the number of stripes. I will provide a video clip that will make you much clear about the construction, how actually this transformer made up of is a vivid diagram. I am giving you the number of stripes, alright, in a particular pattern, and it is stapled. Remember, it is stapled at the corners like this way. Okay, these screws are stapled. Now, my dear students, look at here. The terms, it is given the primary and secondary as input and output. Actually, this core of transformer used to transmit the magnetic flux, which is formed by the coils. Look at here, I am giving the number of turning. These are the coil over transformer. This section, it is input section. Input section basically obtained at primary coil. This is called the primary coil. It has certain number of turning, and this will be considered as the NP, number of primary turns. Here there will be another turning of different number. We will study when it will be increased and when it will be decreased. But this is the output segment. Okay, you can also study its resistance as R input, its resistance as R output. We know that if this is the wire, of course it should have some resistance, so it can be written as the RIRO. And this is the secondary. This number of turning, it is called the turns of secondary coil, and this is called the secondary coil. Secondary coil. Okay, my dear students, this is the structure of this is the input and output section. Output section. This is the vivid diagram of transformer. All right. While in construction, you should write in examination point wise. Alright, so we know that it consists with two coils, primary coil and secondary coil. Primary coil will give you the input, or we supply the input at primary coil and we obtain output at secondary coil. Alright, both the coil looks like solenoid. You can see it looks like a solenoid in which soft iron cores are inserted. To understand the clear picture of transformer, my dear students, look at here over this video clip. Alright, then after we will do the calculation and we will land up to the transformer ratio for numerical problems. Okay, my dear students, look at here.
Long distances to a substation. Transformer changes the very high voltage electricity back into lower voltage electricity, so it can be used safely in our homes and different factories. There are mainly three parts of a transformer, namely 1. Primary circuit, 2. Core, 3. Secondary circuit. Primary circuit. The primary circuit is connected to the input energy source. The current, potential difference and coil in the primary circuit are called the primary current LP. Core. Transformer consists of the rectangular soft iron core made of laminated sheets. The sheets are well insulated to each other. The function of the core is to transfer the changing magnetic flux from the primary coil to the secondary coil. The secondary circuit is connected to the output of the transformer. The current, potential difference, and coil in the secondary circuit are called the secondary current, Ls, secondary potential difference, Vs, and the secondary coil, Ns, respectively. Working principle of transformer. When an alternating voltage source Vp is applied to the primary coil, the resulting current produces an alternating magnetic flux which links the secondary coil and induces an EMF in it. So, transformer works on the principle of mutual induction of two coils. Types of transformer. Step-up transformer. Transformer that increases the voltage is called a step-up transformer. The number of windings in the secondary winding Ns is greater than the number of windings in the primary coil Np. Step-down transformer. Transformer that decreases the voltage is called a step-down transformer. The number of windings in the primary winding Np is greater than the number of windings in the secondary coil Ns.
I hope, my student, you got the clear picture of transformer using that clip. Now we are going to do some calculation, the calculative part of this transformer that will help you to solve the numerical question. Okay, remember, for this calculative part we have taken some assumptions. Okay, and that assumptions are the three assumptions, my dear students, we have to take. It is mentioned clearly in NCERT also. These assumptions are: the first one, on this assumptions we will do the calculations. The first assumptions, it is the primary current, that is the current in primary coil, and its resistance. Alright, resistance of primary coil should be very small. Alright, should be small. Second assumption, that flux that is produced by the primary coil, here I just rub the diagram, primary coil, it should be equals the flux linked with the secondary coil. Alright, and the third one, it is the current in secondary coil also should be small. Alright, it should be also very small. On this assumption, remember, these are assumptions made for the ideal transformer. Ideal transformer. Alright, so for ideal transformer, my dear students, we can write, look at here this equation. Okay, but before that, in primary, try to look at the picture that you have made. Kindly make that picture over the copy. So this was our coil. Alright, here it was the primary coil and it was the secondary coil. Alright, so my dear students, if flux it is produced by, since it is a magnetic field here and here, this magnetic field also. Alright, so the magnetic field produces the flux linked with the primary coil. It can be written as phi p as minus n d, and it is for the primary coil d phi by dt. Alright, and for secondary coil we can write phi as, it is minus ns d phi by dt. Remember, for the primary coil, and this is the secondary coil. What this assumption actually gives the idea, so it gives the idea d phi p by dt, it should be equals to d phi s by dt. Alright, so my dear students, we can write, if these are constant, my dear students, from where we got this equation? From Faraday law of electromagnetic induction. Oh, sorry, this is the EMF, EP and ES. So Faraday law of electromagnetic induction. My dear students, if we'll get the ratio of these two, what we'll have? EP over ES, it is equals to, this will be the cancel out, minus minus will cancel out, NP over NS. I hope you understand. Suppose this is our equation A. Now my dear student, how this actually flux linked with the coil? So this soft iron core help to find the path for this flux, and it flux linked with the completes the path using the soft iron core, alright, which is a ferromagnetic substance. Now the second thing, we know that for ideal transformer there should be no power loss. The power at the input, that is the primary coil, should be the power at output at the secondary coil. So now if no power loss, consider, remember this is impractical my dear students, this is totally impractical because we cannot have any transformer in which there will be no loss of power or the energy. But here ideal case we are taking, in this case the power at primary coil should be the power at secondary coil. Alright, in this case we have EP, this is primary coil, ES, IS, and again we will have the ratio of EP by ES, EP and ES as IS and IP. Now this is the equation B. Alright, equation B. My dear students, if you will analyze these two equations A and B, you will have a transformer ratio, and that is the transformer ratio, it is EP over ES equals to NP over NS equals to IS over IP, and this is called transformer ratio. Okay, this is called the transformer ratio. But my dear students, suppose if any transfer we are having which is not 100% efficient, then in that case there will be the loss in different cases. Suppose if any transfer having the efficiency 80%, alright, or the 70%, in that case what we will do, my dear students? So after knowing the efficiency, we can solve that type of questions also. Actually, when we talk about the efficiency that we have studied from our standard 11th, even in try to recall the Carnot engine, we have studied the efficiency, and in different chapters, even in work power energy, we have discussed about the efficiency. Alright, my dear students. So we can write the efficiency of transformer as efficiency of transformer, as we know that the efficiency is nothing but the output by input. It is represented by this symbol eta, and it is output power divided by input power. How much you have given and how much you got as output. This will be the efficiency. Alright. So times 100%, in percent you will get the efficiency. My dear students, we know that output we will get as at secondary ES, IS divided by EP, IP. But we can convert this formula in terms of number of turns as well as current through secondary and primary coil. Alright, you can replace this ES by EP as NS by NP. Alright, even you can replace this IS by IP by NP by NS. So you will have the formula in different way. Okay, my dear students. Now, we know that in practical transformer, there are the different way of loss of energy. Okay, so we'll write the loss in different form. Loss in transformer in different form. My dear students, I am writing here the different form in which the energy loss, but you have to study by yourself this thing. Alright, don't be dependent over the teacher 100%. So the first, it is the transform loss, the flux leakage. Flux leakage. It could be the loss in power or the energy. My dear, what we have studied, the total flux made by the primary coil should be linked to the secondary coil. If there will be no total flux linked with the primary to the secondary, what will happen? We will lose the formula. That ratio will not stabilized. Alright. So this is the flux leakage. And to maintain this flux leakage, to maintain the low flux leakage, we use soft iron core as a ferromagnetic substance which provides the or which gives the link or canal to the magnetic flux easily linked with the secondary coil. Alright, my dear students. Now the second one is the resistance of winding. Remember, resistance of winding. Suppose the input and output coil having the large number of winding and the high resistance. What will happen? Over the high resistance of input coil, the power it is supplied to the input coil, it will generate the heat energy, and that heat energy will lost. Alright. So we have to just maintain the low resistance in input. As well, output should be also the very low to not lose the energy in form of heat. Now the third one, it is the eddy current. Remember, eddy current. I hope you remember, my dear students, whenever any metallic plate moves inside the magnetic field, uniform magnetic field, or the plate is kept, magnetic field is oscillating, in the both case there will be the eddy current, that is the whirlpool current produced. Here we are using the core of iron, and that core of iron will have certain energy, the surface area. Over that area eddy current form, and we know that the eddy current produces easily the heat energy, and that heat energy will lost, okay, in surrounding, and that will be the loss in transformer, that will be the counted. Now the next one is the hysteresis loss. What is this actually hysteresis loss, my dear students? So due to the continuous change in current, direction of current, the magnetic field also increase and decrease. Due to increase and decrease in magnetic field, alright, in magnetic field, the direction of dipole inside the core of magnets, it changes rapidly. And due to the change in dipole, there must be some potential energy, which potential energy it is transmit or lost in form of heat. So that is the hysteresis loss. And the last one is humming loss. Humming loss. You might have noticed, my dear students, while going through the transformer, if the transformer is over the pole and you are moving, okay, around that pole, you might have listened a humming sound. It is coming from the transformer. What is that actually? When AC current moves through the coil, that is the primary and secondary coil, if the winding is stapling of the coil is not very perfect, if after some time it becomes loose, then the AC current having some frequency, and that frequency that energy start oscillating the core of the iron. If that core of the iron oscillates due to the frequency and the oscillation match with the frequency of AC, they produces sound due to the resonance. Alright, and that sound, of course, if that sound is coming from transformer, of course it is the conversion of energy, so that energy is lost. The humming sound you are getting, it is lost in surrounding, so this is called the another loss in transformer. So this is all about the transformer, my dear students. Alright, now what we have to do, we have to focus over the numerical question. The numerical question will be very easy, my dear students. Let me solve two questions that are very simple. Alright, the very simple question. After that, you will be able to solve all the questions of transformer. So, the first question, my dear students, let me solve here for the transformer. Okay, so look at here. The first question. Power transmission need input power at... First question. Power transmission need input power at voltage of 2300 volt. Of course, this is the voltage you have to give at the primary coil. Am I right? Yes, it should be at primary coil. With the number of turns in primary coil as 1000 turns. 1000 turns in 4 layers. So, what will be the total number of turning here? Okay, we will do the solution. What should be the total number of turning? You have to find the number of turning in secondary coil for output voltage. You have to find the number of turning in secondary coil for output voltage of 23 volt. Alright, this is your question. 23 volt. Alright, it is 230. Otherwise the value will be very high. Now, could you solve, my dear students? If you can solve this question, try to pause the video and solve this question. My dear students, what we have to write actually? We have to write the formula EP over ES as, we know that, NP over NS. Okay. Do we have the value of EP? Yes, we have. It is 2300. Do we have the value of ES? Yes, we have 230 volt. Now, do we have the value of NP? Because we have to find the NS. Yes, we have the value of NP. Remember, students, here the 1000 turn in 4 layer. It means the NP will be the 4 times 1000, which is the 4000. Alright, putting all the values, my dear students, I hope you can solve this question. Alright, now the second question. I think after solving all this value, you will get the 400 turns. What is value? 400 turns. You should solve by yourself. Okay, now the next question, my dear students. In next question, you have to find the input current. Find current at primary coil. Okay, you have to find current at primary coil. If a coil which is stepped down by device, all right, this is to be stepped down a device by 200 volt, which is stepped down from 200 volt to 20 volt. 200 volt to 20 volt. All right, and it is to be operate a device of you have to give this as the at output circuit, right, of 20 ohm, and you have to assume it's not ideal transformer. Assume efficiency as 80%. Okay, my dear students, could you solve this question? Let me make this question as a homework. Alright, what should be the answer? After solving, you will get the answer as 120. What you have to find? IP. So you will get the answer as IP 125 milliampere. If you can solve, my dear students, try to solve. Otherwise, I will explain. I will discuss this question in group. Okay, my dear students. So this is all about today's lecture, my dear students. Thank you very much.